Hello and welcome to my channel. In this video we are going to solve question number 1 to 6 from exercise 3.3 from Matrices chapter. So let us start with the first one. Find the transpose of each of the following matrices. Now here 3 sub-questions are given and I have already solved the first sub-question. Now let us first understand what does transpose mean. A transpose of a matrix is one in which the column turns into a row or a row turns into a column. So you can see it in both the ways. Now here in the first sub question we can see that a column matrix was given because it has just one column. So 5, 1 over 2 and minus 1 were the elements of this column. Now when we take the transpose of this matrix, the 3 rows have got converted into one row. So you can see that this column has turned into a row. So it's the same elements but the column has become a row now. So this is the transpose of the first matrix. So let us move on to the second sub question. Now here we are going to take the transpose of the original matrix. So let us consider the first column, that is 1 and 2. So this first column we are going to change it into first row. So you can see 1 and 2, which were the elements of the first column, has now changed into the elements of first row. Now similarly the second column elements we are going to put it as second row elements. So minus 1 and 3, the column elements have become row elements, that is minus 1 and 3. So remember, transpose is changing the columns into rows, or you can also say it as changing the rows into columns. Now let us move on to the last sub question. So here the third sub question is a 3 by 3 square matrix. So we are going to take its transpose. So the first column elements turns into first row elements. So here we have minus 1, square root of 3 and 2. Now the second column changes into second row. So here 5 and 3. Now finally the last column elements will change into last row elements. So we have 6 and minus 1. So these are the transposes of the given matrices. Now let us move on to the second question. If A and B are two 3 by 3 square matrices, then verify that A plus B the whole transpose is equal to A transpose plus B transpose. And the second sub question is A minus B the whole transpose is equal to A transpose minus B transpose. So here we have to show that the left hand side is equal to right hand side. So let us start with the first sub question now. Now here we are going to start with the left hand side, that is A plus B transpose. So before we find out the transpose of A plus B, let us find out what is A plus B. Now here for the addition between the matrices to take place, the order of both the matrices have to be same. So A and B both are 3 by 3 square matrices, so we can perform the addition. So here we have written matrix A plus matrix B and then we have added them element by element. That is minus 1 plus minus 4 is minus 5, 2 plus 1 is 3, 3 plus minus 5 is minus 2, 5 plus 1 is 6, 7 plus 2 is 9, 9 plus 0 is 9, minus 2 plus 1 is minus 1, 1 plus 3 is 4 and 1 plus 1 is 2. Now once we have got the value of A plus B, we are going to find its transpose. So here we have written A plus B transpose. Now here we are going to change the columns into rows, starting with the first column. The first column becomes the first row. So here we get minus 5, 6 and minus 1. Now the second column changes into second row. So we get 3, 9, 4 as the row 3, 9, 4. Now the last column changes into last row. So we get minus 2, 9 and 2. So column into row. Now let us consider this as equation 1. Now let us focus on the right hand side. That is A transpose plus B transpose. So let us first find out A transpose. So here we have taken A and B matrix for easy reference. So you can see in the A transpose we have made each column into a row. So minus 1, 5 and minus 2, the first column elements have become first row elements in A transpose. Now the same steps we have performed for the second column and third column. So second column is second row and third column is third row. Same thing is being done for the B matrix as well. The first column has become first row and similarly for second column and third column. Now once we have got the values of A transpose and B transpose, the right hand side says to find out the addition between these two. So let us add A transpose and B transpose now. So these are A transpose elements plus B transpose elements. The orders are same, so we can perform the element by element addition. Now after adding these two matrices, this is our resultant matrix of A transpose plus B transpose. So let us consider this as our equation 2. Now let us compare the elements of equation 1 and equation 2, starting with the first row elements. So here in the first row you can see that it is minus 5, 6 and minus 1. Here also we have minus 5, 6 and minus 1. Second row elements are 3, 9, 4. Here also we have 3, 9, 4. And finally the last row elements are minus 2, 9, 2. So we get minus 2, 9, 2. So the left hand side has become equal to right hand side. So let us write here. The left hand side, which was A plus B the whole transpose, is equal to A transpose plus B transpose, which is verified. Now let us move on to the second sub question, that is subtraction. So here we have A minus B the whole transpose is equal to A transpose minus B transpose. So again let us start with the left hand side. So before we find out the transpose, let us find out A minus B. So here these were the given A and B matrices. Now subtracting B from A, we get minus 1 minus of minus is plus 4. So minus 1 plus 4 gives us 3. 2 minus 1 is 1. 3 minus of minus is plus. So 3 plus 5 is 8. 5 minus 1 is 4. 7 minus 2 is 5. 9 minus 0 is 9. Minus 2 minus 1 is minus 3. 1 minus 3 is minus 2. And 1 minus 1 is 0. Now once we get the elements of A minus B, we are going to find its transpose. Now here we have written A minus B the whole transpose. So the first column becomes first row, second column becomes second row, and third column becomes third row. And let us consider this as equation 1. Now we have already got A transpose and B transpose in the previous part of this question. So let me reconsider it. So here we have considered A transpose and B transpose. And now we are going to take the difference between A transpose and B transpose. So subtracting these two matrices, we get these elements. And let us consider this as equation 2. Now comparing the equation 1 and equation 2 elements, the first row is 3, 4 and minus 3. Here also we get 3, 4, minus 3. Second row is 1, 5 and minus 2. Second row is 1, 5 and minus 2. Finally the last row, that is 8, 9 and 0. Here also we get 8, 9 and 0. So here we have again proved that the left hand side equal to right hand side. So we have written A minus B the whole transpose is equal to A transpose minus B transpose, and it is verified. Now let us move on to the third question. If A transpose is given by a 3 by 2 matrix and matrix B as 2 by 3 matrix, then verify that A plus B the whole transpose is equal to A transpose plus B transpose. And the second sub question is A minus B the whole transpose is equal to A transpose minus B transpose. Now this is very similar to the previous one. The only difference is in the orders of A transpose and B. And one more difference is here A transpose is given. So we will try to find out A first. So let us start with the first one. Now here the A transpose matrix is taken. And to find A, we are going to perform the exact same steps which we performed in finding the transposes. So here the column changes into a row. So from A transpose we are going to get A by changing the column into a row. So 3 minus 1 0, the column elements have become the row elements. Similarly the second column becomes the second row. So once we have got the value of A, let us focus on the left hand side, that is A plus B. Now here matrix A plus matrix B. Now you can see the orders of matrix A and B are same, that is 2 by 3 and 2 by 3. So we can perform the matrix addition element by element. So 3 plus 3 is 6, minus 1 plus minus 1, that is minus 1 and minus 1 gives us minus 2. 0 plus 3 is 3, 4 plus and minus is minus, so 4 minus 1 is 3, 2 plus 0 is 2 and 1 plus 2 is 3. So these are the elements of A plus B. Now let us find out the transpose of A plus B. So here we have written A plus B the whole transpose is equal to, now the first column has become first row, second column has become second row, and third column has become third row. Now let us consider this as equation 1. Now let us focus on the right hand side, that is A transpose plus B transpose. Now in the question A transpose was already given. So let us try to find B transpose now. So here we have taken B matrix and taken its transpose. So first column has become first row, second column second row, third column as third row. Now we are going to perform the A transpose plus B transpose operation. Now again the orders are same, so we can perform the element by element addition. So 3 plus 3 is 6, 4 plus and minus is minus, so 4 minus 1 is 3, minus 1 plus and minus is minus, so minus 1 is minus 2, 2 plus 0 is 2, and 0 plus 3 is 3, finally 1 plus 2 is 3. So this is our equation 2. Now comparing the elements of equation 1, that is left hand side, with the equation 2, right hand side, we can see that all the elements are same. So first row equal to first row, second row equal to second row, third row equal to third row. So here, since 1 is equal to 2, that is equation 1 equal to equation 2, we can say that the left hand side A plus B the whole transpose is equal to the right hand side A transpose plus B transpose. So it is verified. Now let us move on to the second sub question, that is with subtraction. Now A minus B transpose is equal to A transpose minus B transpose. So here we have taken A transpose, B transpose, A and B matrix as we had got in the previous sub question. Now let us focus on finding out A minus B first. So A matrix is 2 by 3 matrix minus B is 2 by 3 matrix. Since the orders are same, so we are going to perform element by element subtraction. That is 3 minus 3 gives us 0. Minus 1 minus of minus is plus. So minus 1 plus 1 is 0. 0 minus 3 is minus 3. 4 minus of minus is plus. So 4 plus 1 is 5. 2 minus 0 is 2. And 1 minus 2 is minus 1. Now once we have got A minus B, let us take its transpose, that is left hand side. So when we take the transpose, the column becomes the row. So we can see 0, 5, the column elements have become the row elements. Second column becomes second row and third column becomes third row. So let us consider this as equation 1 since this is our left hand side. Now let us focus on the right hand side, that is A transpose minus B transpose. So here we are going to subtract these two matrices. So here we have written A transpose minus B transpose. Now here also the orders of the matrices are same, that is 3 by 2 and 3 by 2. So element by element subtraction gives us 3 minus 3 is 0. 4 minus of minus is plus. So 4 plus 1 is 5. Minus 1 minus of minus is plus. So minus 1 plus 1 is 0. 2 minus 0 is 2. 0 minus 3 is minus 3. And 1 minus 2 is minus 1. Now this becomes our equation 2. Now we have to compare the left hand side matrix with the right hand side matrix. So if you see these matrices, they both are exactly same. The first row equal to first row, second row equal to second row, and third row equal to third row. You can also compare the columns. So the first column equal to first column and second column equal to second column. So here we have verified that the equation 1 is equal to equation 2, that is left hand side equal to right hand side. So we are going to write A plus B the whole transpose is equal to A transpose plus B transpose, and it is verified. If A transpose and B are two 2 by 2 square matrices, then find A plus B the whole transpose. So here in this question we can see that A transpose is given, but we have to find A first to find A plus 2B the whole transpose. So let us find out A first from A transpose. So this is the given A transpose matrix. So for finding A, we are going to make the column of A transpose as the row. So you can see the first column has become the first row of A matrix and second column has become the second row. Now once we have got A matrix, let us focus on A plus 2B. Now in A plus 2B, we have first written the A matrix which we got just now plus 2B. 2 is a scalar quantity which is getting multiplied with each and every element of B matrix. So 2 multiplies with minus 1 giving us minus 2. 2 times 0 is 0. 2 times 1 is 2 and 2 times 2 is 4. So this is matrix A and this is matrix 2B. So we have to perform the addition between these two, and since their orders are same, we are going for element by element addition. So minus 2 plus or minus is minus. So minus 2 gives us minus 4. 1 plus 0 is 1. 3 plus 2 is 5. 2 plus 4 is 6. Now we have got A plus 2B matrix. Now let us find its transpose. So when taking the transpose, the first column of a plus 2b becomes the first row and second column becomes the second row. So this is the answer we are looking for, that is a plus 2b transpose. Now let us move on to the fifth question. For the matrices A and B, verify that A times B the whole transpose is equal to B transpose times A transpose, where now two sub-questions are given. So here let us start with the first sub-question. So here we have been given the matrices A and B, and we have to again verify that the left hand side is equal to right hand side. So let us start with the left hand side, starting with the multiplication between the matrix A and B. So here we have written the matrix A times matrix B, but before we perform the multiplication, let us understand what will be the order of the resulting matrix. Now matrix A is 3 by 1 matrix, that is it has 3 rows and 1 column, and matrix B is 1 by 3 matrix, that is it has 1 row and 3 columns. So if we have to multiply two matrices, the condition is the number of columns of the first matrix should be equal to the number of rows of the second matrix. So here 1 is equal to 1. So we can multiply these two matrices, and the resulting matrix is going to be of the order 3 by 3, which means we are going to have a matrix which has 3 rows and 3 columns. So this is going to be the resulting matrix. So let us understand how we have got these elements. So the first row element 1 multiplies with each and every element of the second matrix. So 1 times minus 1 gives us minus 1, 1 times 2 is 2, 1 times 1 is 1. So since we know there have to be 3 columns, we have got 3 columns. Next, the second row element multiplies with each and every element. So minus 4 times minus plus 4, minus 4 times 2 is minus 8, minus 4 times 1 is minus 4. Now the last row, that is 3 times minus 1 is minus 3, 3 times 2 is 6, and 3 times 1 is 3. So this is how we got 3 rows and 3 columns, giving us 3 by 3 resulting matrix. Now once we have got A times B, we have to find its transpose. So here we have taken the transpose, that is the first column of AB has become the first row of AB transpose, second column becomes second row, and third column becomes third row. Now once we have found out the left hand side, let us focus on the right hand side, that is B transpose times A transpose, which means we need to find out the A transpose and B transpose from these two given matrices. So let me write here. So here we have taken the A matrix and taking its transpose, the column becomes the row. Similarly for B transpose, the row becomes the column. So now we have to multiply B transpose with A transpose. So here we have written the B transpose matrix and A transpose. Now let us again find out what is the order of the resulting matrix. Since the number of columns is equal to number of rows, that is here we have 3 rows and 1 column, and this matrix is 1 by 3 matrix. So the number of columns will be equal to the number of rows. So the resulting matrix is of the order 3 by 3 matrix here again. So let us start with the multiplication. So here again the first row element multiplies with each and every element of the second matrix. Minus 1 times 1 is minus 1. Minus 1 times minus 4 is 4. Minus 1 times 3 is minus 3. 2 times 1 is 2. 2 times negative 4 is negative 8. 2 times 3 is 6. 1 times 1 is 1. 1 times negative 4 is negative 4, and 1 times 3 is 3. Now if we look at the previous matrix, that is AB the whole transpose and B transpose A transpose, we can see that every element in this matrix is equal to every element in this matrix. So first row is equal to first row, second row is equal to second row, and third row is equal to third row. So here we have proved that the left hand side is equal to the right hand side. So let me write here. AB the whole transpose is equal to B transpose times A transpose, and it is verified. Now let us move on to the second sub-question. Now for the second sub-question, A and B matrices are given, and we have to prove the same thing, that is AB transpose is equal to B transpose times A transpose. Now I have written the A transpose and B transpose matrices over here. So you can pause the video and give it a try and try to verify that the left hand side is equal to the right hand side. So here let us start with the left hand side, that is multiplying the matrices A and B first. So here we are going to multiply the A matrix with B matrix. So this is again 3 by 1 matrix and 1 by 3 matrix. So performing the multiplication, we get a 3 by 3 resulting matrix. Now we are going to take the transpose of AB matrix. So here we have written AB transpose is equal to, now the first column becomes first row, second column becomes second row, and third column becomes the third row. Now once we have got AB the whole transpose, let us find out B transpose times A transpose. And for that we have taken their values over here. So B transpose times A transpose is again a 3 by 1 matrix and 1 by 3 matrix multiplication, giving us a resulting matrix of the order 3 by 3. Now multiplying it, we get these elements. So here we can see that AB transpose is equal to B transpose times A transpose, because each row or each column of AB the whole transpose is equal to each row or each column of B transpose A transpose. So here we have proved that the left hand side, that is AB the whole transpose, is equal to B transpose times A transpose. So it is verified. Now let us move on to the sixth question. If A is a 2 by 2 square matrix, then verify that A transpose times A is equal to identity matrix. Now in this question we have two sub-questions and we have to prove exactly the same thing, that is A transpose times A is equal to identity matrix. So let us start with the first sub-question. So here we have written the A matrix, which is a matrix of trigonometric functions, that is cos alpha, sin alpha and so on. So the first step is to find its A transpose. So the first column of A has become the first row and the second column has become the second row. Now the next step is performing the left hand side operation, that is A transpose times A. So here we have written A transpose elements times A elements. Since both are 2 by 2 matrices, the resulting matrix is also going to be 2 by 2. So let us start with the multiplication. Starting with first row and first column multiplication, cos alpha times cos alpha gives us cos square alpha, plus minus times minus is plus again. So plus sin alpha times sin alpha gives us plus sin square alpha. Now the first row and second column, cos alpha times sin alpha is written over here, plus with a minus gives us minus. So minus sin alpha times cos alpha gives us minus cos alpha sin alpha. Now the second row and first column, sin alpha times cos alpha, and then cos alpha times minus sin alpha gives us minus cos alpha sin alpha. Now the second row and second column, sin alpha times sin alpha is sin square alpha, plus cos alpha times cos alpha is cos square alpha. Now let us simplify this matrix. So cos square alpha plus sin square alpha is a trigonometric identity which is equal to 1. So in place of the first element we have replaced 1. Now cos alpha sin alpha minus cos alpha sin alpha will go down to 0. They will add up to 0. Now the third element also will add up to give us 0, because they are the same elements but with opposite signs. And finally we get the last element, that is cos square alpha plus sin square alpha, again as equal to 1. So the matrix simplifies as 1 0 0 1, and this is going to be the identity matrix of the order 2 by 2. So here we have verified that A transpose times A is equal to identity matrix. Now let us move on to the second sub question. Now this is the given matrix A. So we have to find its transpose first. So the first column has become first row and second column has become second row. Now performing the multiplication between A transpose and A, again we are going to get a 2 by 2 resulting matrix. So let us start with the multiplication, that is first row and first column. So sin alpha times sin alpha gives us plus sin square alpha, and minus cos alpha times minus cos alpha gives us plus cos square alpha. Now first row and second column, sin alpha times cos alpha minus cos alpha times sin alpha. Now the second row and first column, cos alpha times sin alpha plus sin alpha times minus cos alpha gives us minus cos alpha sin alpha. Now second row and second column, cos alpha times cos alpha is cos square alpha, plus sin alpha times sin alpha is sin square alpha. Now again let us simplify this matrix. Cos square alpha plus sin square alpha will be equal to 1. Now the second elements both are same but with opposite signs, so they will add up to give us 0. Now the third elements, they are also same but with opposite signs, so they will add to give us 0. Finally cos square alpha plus sin square alpha will be equal to 1. So this matrix also simplifies as 1 0 0 1, which is equal to the identity matrix. So we have verified that A transpose times A gives us identity matrix. I hope you have understood all the steps and liked the video, and if you found this video useful, then check out these playlists where you'll find more examples of these kind. And if you're liking my videos, like, share and subscribe to my channel, and thank you for watching.